You guys have all done this before. What we're looking at here today is nothing more than really combining like terms. You're combining like terms with this stuff. Those of you that have had me before, you might have heard me, or might even heard me say this before. Don't do horizontal math. Got it? Don't do horizontal math. Horizontal math is the root of the devil. It's from the devil. It's much easier to add things vertically. It's easier to multiply. It's easier to do all that stuff when you work things vertically. So when you're given problems like this, and you have to add two things together, instead of writing it out like that, I'm going to immediately, since I'm adding, just line them up. So if I'm looking at a problem like this in my book or whatever, I just put it in a descending order, 3x cubed plus 2x squared minus x minus 7. And since I'm adding all of that, I'm distributing a positive 1 value to everything. I can just line them up. X cubed minus 10x squared plus 8. And I combine my like terms. Okay. It is that straightforward. When you're combining like terms, you have to make sure that you have the same variable, same exponent. None of that has changed. So here you wind up with 3x cubed plus x cubed. What do you get?
4x cubed.
Okay. 2x squared minus 10x squared. Minus x, and then negative 7 plus 8. Any questions? All right. When you're adding and subtracting using horizontal math, it's just awful. Okay. What you guys are going to screw up though is this. You got to distribute the negative. This is exactly what you guys are going to screw up. When you're subtracting these polynomials together, again, what I would do is I would start writing it vertically. I know that it's 5x squared plus x minus 7, and I'm subtracting 3x squared minus 6x minus 1. And here's what I do a little bit differently than you might have seen in the past. Does everybody agree that I'm subtracting the entire bottom polynomial? And then when we do that, we're combining all the like terms, right? Here's what I do. I put a subtraction symbol in between all the terms. That way I take them one at a time. 5 minus 3. 1 minus negative 6. 7, good. If you want, that's fine. It's fine. It's fine. It's absolutely fine. All right. And then the last one, negative 7 minus negative 1. Negative 6. This is the way that I do it. That's all. That's all I'm doing. That's all I'm doing. That's exactly what I'm doing, Eddie. That's exactly what I'm doing. Okay? I know that there's many other ways, like you were saying, Anna, if you want to distribute out the negative right off the bat as you write it, it's fine. There's nothing wrong with that at all. Whenever I've done subtraction, I've always written it that way vertically, and just put the subtraction in between each term. I just think that by doing it that way, it just forces me to remember that I'm subtracting everything. Because that's what you're going to screw up. That's really all you're going to screw up here, is the negatives, because I know how you guys work. Bless you. All right. So take a second and try these awfully difficult problems.
Yeah.
Yes, I am. But at the same time, I'm not.
Sure. Line them up. Now, in this case here, do I have to put placeholders in if I want? I can. I'd have to put 2 in the bottom, 1 in the top, but I'm hoping that you guys don't even need to worry about it. So with any luck, you got this right. 6x to the 4th. Those go away. Plus x squared plus x minus 8. You got a haircut. I can see your ears.
Thank you for noticing.
Well, I mean, you can see them a little bit.
And also, I'm the front, how are things trying to grow?
You can see his more. It's not really exceeding.
No, that's not a mullet going there. I mean, he's got to have a little bit less off the top. So here's the tough stuff. Multiplying. What do you have to be careful with when you're multiplying?
The signs.
The signs and exponent rules.
Yes.
When you're multiplying two variables together that have the same variable, what do you do to their exponents?
Add them.
You add them. So you wind up here, you have to distribute out twice and then combine like terms. There's no magic foiling method for doing a binomial to a trinomial. It's nothing more than just distributive property twice. Okay? Yes, ma'am?
Are we ever going to divide?
Yes. We will. And then we do that, what's that? I think it's 6-5. It's kind of cool. We're going to do it both long division and short division.
I'm feeling related.
No, long division is pretty cool.
Oh, I remember long division.
So distribute out, you get 3x cubed minus 2x squared minus 4x minus 9x squared plus 6x plus 12. At this point then, it is a lot of junk. You just combine all of your like terms. Always put it into a descending order. Suggestion that I would do as you're going to write your stuff into your descending order, start crossing off what you're using. Yes, ma'am?
Why did they teach us to write stuff in ascending order?
I don't know.
Because like we never use it, and
Well-
it's kind of just stupid.
You have to learn how to drive in reverse, right?
Yeah.
You can pull it off.
You do that, but you don't use it as often, though, as you do driving forward, right? Am I right?
You are.
You're not driving around backward. I mean, you're not like, unless you're driving a forklift a lot.
I'm driving a forklift.
Do you know it's safer to drive a forklift backwards than it is forwards?
Did not know that.
It is, because when you're driving a forklift forward, you have forks in front of you, so you can spear somebody.
I drove one of those around all day.
Forklifts? It's fun.
It's really hard, but it's really cramped areas.
Yeah.
Not fun. Well, I mean, it's fun, but it's not.
Really, guys, as you go through these things, you're going to find that this is not a very difficult section at all. It is very, very straightforward. Watch your signs, watch your combining like terms, okay?
Does it get any harder than this for this chapter?
It will, but adding and subtracting and multiplying is the easy stuff.
I need to start this one down.
But, oh, guys, once again, the reason I cross those off, Ben, is because as I'm writing them down, that way I don't go back and re-add them together. I'm just looking at them as I wrote down the 3x cubed so I could cross it off the list. I got negative 2x squared and negative 9x, combine them, got them out of the way. Negative 4x and 6, I got a 2, and so on. It's helping me keep track of what I'm doing. So take a second on those two. Division, which, like I said, we'll get to later this week, is you're doing a lot of subtraction, you're doing multiplying, you're combining like terms, you're using your exponent rules as you're going through, okay? We will, this is really quite simple, all right? It looks god-awful. Let me ask you this. How do you turn an x squared into a 2x to the fourth? What do you have to multiply it by?
X squared.
By 2x squared, right? So I multiplied it by 2x squared. So I distribute it into 3 terms. I subtract out. I'm left with 7x cubed. How would I turn an x squared into a 7x cubed?
7x.
Multiply by 7x. Distribute it out, I get this. And so on and so forth. We'll get to this stuff later. Did you have a question on either of those two that I just showed you? You want me to walk through it real quick, or are you all right? One of the things that I would do on this first one, what I would have done on the first one, which I bet nobody did, I would have worked the other direction. Nice! Well, I knew I liked you for some reason. Oh, wow. Did you? I like you too. Why did you do it that way? Less work. The reason why it's a little bit less fitting, in the grand scheme of things, isn't the same amount of work. But it's a little bit more, it's a little bit easier to set up. Now, if you wanted to go the other way, that's fine. By working the other way, I just thought to me, it just makes more sense to do it that way. Combine them out, you get 8x cubed, 2x squared, that one. You're right?
Yes.
I didn't think we would do it that way. I'm not going to do the next one this morning. Oh no! I am so afraid. Guys, I don't have that much left here. Okay. What happens when you wind up with a bunch of binomials being multiplied together like this? It's just the two terms where you'd be foiling. What I would do is find the two that are the easiest to multiply together first. Sometimes you'll find a special pattern, like a plus minus the same number. You might get a difference of squares. Okay? If you recognize some of those, it's just a little bit quicker to work with. If not, you just multiply them two together, and then you multiply the third one together. Okay? Don't try to distribute, or don't try to multiply all three of them at the same time. You'll never get it right. Just FOIL it out and go. For example, in this case, I'm just going to FOIL the first two together, get x squared minus 3x plus 2, and then I'm left with multiplying that by x plus 3. Because remember, does order matter when you're multiplying? No. What's the property? For 1 million, you got it without the 0 points, because I was going to give you 1 million points.
Oh, man. Hate when that happens.
The question was, what's the property that tells you that you can multiply in any order? What is it? The property of the commutative property.
Wait, is there?
There's multiplicative is part of it. Transitive property is your law of syllogism. No. I am older than you. You are older than your little sister. Therefore, I am older than your little sister. I don't know if you have a little sister. Your little brother. Therefore, I'm older than your little brother. Do you agree? That's law. That's transitive property. Not really. Not really. I'm not going to bother doing this with these things. To be honest with you guys, the worst thing you're going to do is you're going to, forget that 9 plus 2 is 11, or a negative. You're just going to make a bonehead mistake. So this is really quite simple material. Just take the extra 5-10 seconds to make sure you're not screwing something up. What did I screw up?
Isn't 2 minus 9 and 7?
I haven't. Wait, what?
You said.
You said 11. Oh, were you talking about?
Yeah, I'm just saying I'm not done yet. I'm getting there. I'm like, I hope I didn't screw this up yet. I mean, I wouldn't be surprised, but you never know. Those just drop out. One of the things that I want to show you, this is not something I'm going to make you memorize. This is just something that if you start to recognize special patterns. For example, if you recognize special patterns, that's a difference of squares. Okay? The FOILed out version of that is x squared minus 4. It just makes your life easier. It's quicker. Okay? Whereas if it was x plus 2, I don't want to use 2. If it was x plus 4, x plus 4, this is, it's not x squared plus 4 squared. Perfect squares. One of the patterns that happens with perfect squares, if you have the same term twice, square the first, square the second, multiply them together and double it. The quick way of doing it again, square the first, square the last, 5x, and double it. It's the quick pattern, okay? This is that same idea of x plus 5 quantity squared. That does not equal x squared plus 25.
But I like killing puppies.
We don't like killing puppies, okay? Just remember. One of the things that we will get to a little bit more, we don't see it that often. No, we did this one. I will suggest one thing. When you come across a problem that does have something being cubed, and it's junk cubed, that means junk times junk times junk. If we had x plus 6 cubed, I would like you to try this pattern. If you recognize this pattern now, when we factor stuff starting on Wednesday, it'll be a little bit easier because we will have to factor some cube roots. All right. So what happens here is that you've got two parts, the x and the 6. You'll notice how how the degrees change as they go through. There's a reason for that. Binomial expansion. First term cubed plus 3 times first term squared times the other term plus 3 first term, second term squared plus last term cubed. What I want you to do is notice that the degrees of the first term, the x, are descending. Cube, squared, 1, 0. Because there's nothing there. X to the 0 is 1. The other ones are, here's your ascending order. The 6 starts at 6 to the 0, 6 to the first, 6 squared, 6 cubed. Fancy schmancy. There will be ways of telling the, there is something called the binomial expansion theorem that we will discuss, that there's another pattern that happens for larger ones as well. Okay? But it bases off the same idea. The degrees are decreasing where the degrees are increasing. It's pretty easy to go through. Now, when it's the other version of that, when it's squared, or excuse me, when it's subtraction, you just have to be careful with your signs. Okay? So if it is x minus 5 cubed, your signs are just going to alternate. The exponent trick still works the same. It's just first term's positive, second term's negative, third term's positive, fourth term's negative. It just goes like that. Okay, that's how it works. Another way to remind yourself of that is if I took negative 5 times negative 5 times negative 5, would that be positive or negative? Negative. All right, so that's one way to remember that the last term's going to be negative here. So this is x cubed minus 3 times x squared times negative 5. Oops, sorry, just 5. Plus 3 times x times 5 squared minus 5. What's that?
Why is 5 positive and negative?
It's just taking the value. It's just taking the value of b. That's all it is. It's not like h's and k's here. It is that. All right? Obviously, I could leave it up to you to square 5 and multiply it by 3. Yes, ma'am?
Well, you said that all the signs change. How come it's still adding 3 to the square? Is it something?
It happens, if you multiply it all out, what happens is you wind up with positive, or you'll have 3 positive terms you multiply together, then you'll have 2 negatives and a positive, or 2 positives and a negative. So that's how that stuff works out. That's how that goes if you boil things through. Okay? It's a nice little trick. You can start to play around with it a couple times to give it a shot. So let's do this. It's section 6.3. I forgot what page it is. Go figure.
I'm saying that I'm allowed to, if I wanted That's not yours. Sharing isn't caring.
It doesn't deserve
Sharing is
Oh, yeah.
Anything kills puppies if you wide open paper.
I'm running out of room.
4, 8, 10, 12 problems.
Wow.
That's okay. That's sorry. Come on, you'll have this done in no time. Just watch your exponents. Just watch your rules. Okay? Yeah.